I'm back again with my second video geared off of the heating systems, hot water or steam heating systems. There was a couple of things that I forgot to, that I didn't get a chance to explain to my better knowledge as I reviewed the video that I just posted about the one-pipe steam heating system, especially pertaining to this radiator that's right in the back of me. Now, I did mention how this radiator, or the mistake that I mentioned is that, or what I might have failed to mention is that this is specifically a steam radiator. Now, you have multiple different types of heating systems. The most common type of heating systems that you'll find are the hot water system and the steam heating system, which is primarily in older buildings you'll find steam heating systems. More newer buildings are going with hot water systems, so it seems to be slowly taking over. But in the meantime, I want to give a better illustration about this. And if you take a look here, or right underneath, you see I have various different types of radiators, and I'm going to get to the explaining about those in a second. Okay, there's one thing that I want you to notice between this one here, the little guy that I got right over there with the wide sections, and the one that's currently hooked up in my living room. Alright, and I'm going to get to that in just a few minutes. Now, a common problem that goes on with a lot of steam heating systems, with a lot of cast iron radiators, although they give off the greatest amount of heat and the greatest BTU ratio of heat above any other type of heating system, they've been given a bad reputation off of the fact that a lot of them make a lot of noise and bang. A lot of them are known for leaking, and a lot of this is due to people putting cheap equipment on the radiators. Okay, take a look at some equipment that I have over here. Now, what you're looking at is a setup of, in addition to the tools that I have here and fittings, you're looking at a setup of air valves and two cutoff valves. A lot of people make the mistake of putting one of these type of cutoff valves on the radiator. Even though these might be potentially cheaper when it comes down to installing this on your radiator, it potentially is not a very good choice because they usually tend to wind up leaking. The brass is very thin on the inside, as if you take a look at the lip here, and this is one of the key things that you want to notice when it comes down to buying a cutoff valve for your radiator, is taking a good look at the lip to make sure that the valve is of a certain gauge that it can withstand the heat and intensive pressure and also the weight of the radiator. I'm going to compare this one to a valve that I recommend that be used on radiators, which is the potbelly valve. Now, there was companies that made them back in the days that made them very well, known as Fig, but I don't know if the company's still around. But if you take a good look at the lip, as you can see, it's a very big difference. It's a thicker gauge, meaning a stronger level of brass. Now, take a good look if you still can't understand what I'm talking about. You see the thickness of this gauge here? This is what you want to look for when it comes down to buying a cutoff valve. Not how cheap the price is when it comes down to buying your cutoff valve, because you might also pay a low price for that cutoff valve, but at a plumbing supply store you can probably get you one of these for about $15 to $20, and this can last you a good 10, maybe even 15 years, depending on the way you install it on your system and depending on how little you tamper with it. Buying one of these inefficient valves here, what you normally will wind up happening is you will get leaking that comes between the union, and if this is not a good illustration, so as a matter of fact, let me connect this to one of my radiators so I can better yet show you, or better yet, I got a better idea altogether. Now, although I went against my own advice here, but I put this radiator in a couple of years back, so I didn't have the same knowledge. And as you see, I have one of the same cutoff valves that I do not recommend that you put onto your radiator in itself. Now, as handy as I am, if anything were to go wrong with this cutoff valve, there's nothing that can go wrong with it that I couldn't handle myself. So it really, and I monitor my system quite often, multiple times out of the year, to make sure that I don't have leaks. Now, like I said, a common case where you get leaks at this type of valve is right here under the union on either side, whether it be on the radiator side or the valve side, because the threads usually wind up snapping in some cases, or splitting, or even it just doesn't make a proper seal. Or the next common area, which is a very common area where you get leaks at, is right over here, right above the nut on the spindle. Now, this leak can occur off of constant adjusting of the radiator. Now, when it comes down to a radiator, I recommend that nobody adjust the radiator if you don't have to, because the primary, when it comes down to the one pipe steam heating system, the purpose of that cutoff valve is not to be able to regulate the radiator, but it's to cut off the radiator entirely due to emergencies, or in some cases just in case you get too hot. But even then, I still don't recommend that you do it. Now, there was something that I failed to mention or explain better in the first video. As a matter of fact, let me get my flashlight so I can shine some light on this situation here. Okay. Now, taking a look at this radiator. Now, what I should have explained better is that this radiator here is exclusively, and this radiator might even be over 100 years old, I'm not sure. I pretty much bought this at a refurbished radiator place, and I scraped it down and filed it and repainted it myself, so I made it look just as good as new. But take a good look at two different compartments on the radiator. You have the bottom plug, which I mentioned in the first video, but on top you have no plug. Now, if you take a look at the bottom part of this radiator, you can see that there is a steam column where steam can pass through, basically being distributed or safely delivered between each section and through all the sections. Now, this is only a steam radiator, so if you attempt to hook a radiator like this up on a hot water system, it is not going to work efficiently. It is not going to work effectively. You are going to get a major heat loss. You will get the bottom of the radiator hot. In some cases, if you have an air valve at this point here, you just get heat within this section here, within the back section. But you won't get any heat to the top of the radiator, and you won't even get it to this section here, at least to where the valve is at. You won't even get the water to seep that height because there is air pockets in between these sections. If you take a good look at the top of the radiator, the only connection that you see is these pieces of metal that come out basically to just hold the radiator in place. No steam actually flows in between the sections on the top of the radiator, so the radiator gets its heat distributed strictly from the bottom portion of the radiator. Now, this radiator is a very efficient radiator when it comes down to one-pipe steam systems or even a two-pipe steam system. Either way, it can work just fine. As you see, there's a metal rod that runs in between, but don't let that rod fool you, because that rod does not distribute heat or steam from one part of the radiator to the other. It's solely just to keep the sections together from coming apart. And if you take a look on this side here, you see that the rod is connected at the end with a bolt. So attempting to use a radiator like this on a hot water heating system is a very bad judgment, is a poor excuse. So if you do go shopping for radiators, know what you're looking for. You can hook this up on a two-pipe steam system or a one-pipe steam system. And a common area where you get a lot of banging, like I mentioned in my video yesterday, is with these cutoff valves. A lot of people say that the cast iron radiators make a lot of noise, they bang. Well, a lot of the time why you get problems like this is because people keep the valve partially open. So they'll just say they want a little bit of heat. Instead of the whole radiator getting hot, I'll just want 2 or 3 sections to get hot or somewhat warm. So they'll keep this thing partially open, and what happens is, you got to remember, now taking a look at my system here, this is not how the average system is going to look like when you look at your radiator. More than likely, when you look at your radiator, you're just going to see a floor, and let's just pretend that my hand is the floor, and you'll see the piece of pipe coming out of the ground. You're not going to see a secondary pipe coming out of it into the wall. Now, I would say completely disregard this when it comes down to looking at your heating system, because it's going to all come from one pipe that's usually a 1-inch pipe or 1.25-inch pipe that goes into an 1.25-inch or 1-inch valve. This is altered like this because I had no other choice to get this radiator to heat up sufficiently the way this system is set up. So you would have normally the steam feed coming from the bottom. In this case, the steam feed is coming from this 3/4-inch soldered pipe, which it looks rather corroded because it was put in some years back, and the return goes into this 1.25-inch T. But the problem that happens is you get the water hammering right in this section here, where now when you have the radiator partially open, you have condensated water coming back down from the sections that now build up in this area here, which now basically tries to make its way back into the cutoff valve where you have active steam pushing through. That steam will push through and cause a severe banging. On a radiator like this can be a very severe problem because you can get leaks in a heartbeat. And if your radiator is not properly pitched, and if you take a look at the bottom legs of my radiator here, you see that I have steel washers underneath it to pitch it properly on the back end legs of the radiator. I have wood or plywood just to support it, so I don't put all the weight of the radiator on the valve, because this radiator weighs about 168 pounds. Now, the common problem if you leave these things partially open is that you'll get water that sits in this chamber here that basically builds up in this section here, and there's no other place for it to go to but here. So now you have water squirting out of the back of the radiator air valve, and people in some cases don't know exactly what causes that. So my recommendation to anyone who has a one pipe steam heating system, do not attempt to regulate that radiator. If you get a little hot, it is best to open up the window. It is best, if you have a thermostat to control your heating system through a thermostat, it is best to do that. But if for whatever reason, if you have a private house and you feel you want to just heat up certain rooms because the heating bill is too expensive, I do recommend that you install, well, you can install thermostatic valves, which are very good. But if you have a cover over that radiator and the valve is concealed inside of that cover, the thermostatic valve is going to do you no good. So in the next case, I recommend that you get yourself one of these type of cutoff valves here, which is a thicker brass. These are pot belly valves. This doesn't have a name brand, unfortunately. I think all the name brand companies went out of business, but they just make duplicates of what they used to have. And these will work very effective. But now remember, only keep it all the way on or all the way off. Normally if you have it all the way on, just turn it to the closed position just a little bit. You don't want to have the knob sealed or basically turned all the way to the point where it can't move anymore, because you don't want this thing to freeze together. So give it about a quarter turn in a closed position once you've got it all the way open. Open it up all the way, close it a quarter turn just so the valve or the knob or the handle itself doesn't seal or freeze with the nut. Now, I mentioned how this is a steam radiator. Now they have radiators that look very similar to this that also are universal radiators that do hot water as well as steam. Before I even get into that, I want you to take a look at some various air valves that I have here. Now, a next problem a lot of people are saying, and one guy asked me in one of my videos, I think it was 100% green. You asked me how much steam pressure is known for operating in a steam system or inside of a cast iron radiator. Well, anytime you're dealing with a steam system, you're only dealing with low pressure steam. So you're never going any higher than 15 psi of steam pressure. In most cases, or in any case, you never need that amount of steam to heat up a building, to heat up a house. A lot of people are under the impression that buildings are run under high pressure steam, which no building distributes steam inside of radiators at high pressure. Now, some buildings have a high pressure distributing plant that delivers the steam from underneath the ground or underneath the street to the building at high pressure, but once it is brought back into the building, it is reduced. Normally, I've never seen any building operate any higher than 7 psi steam pressure, which is enough or more than enough to heat up the building in itself. A good pressure, if you're operating a private house, you can use 2.5 pounds of steam pressure to maybe 3 pounds of steam pressure. If you have a pressure troll, make sure that you keep the differential set at about 5 pounds or 2 to 3 pounds or whatever the lowest setting that it is, so you always keep a balance of steam pressure in your system. You never want your steam pressure to die out completely before your boiler kicks back on. But these air valves that I'm showing to you now, alright, this is another common problem where heat efficiency is lost, where you burn a lot of fuel. If you buy cheap air valves, a lot of people will go for vents like this. This is the device that goes onto the back of the radiator of what you see. Now, if you take a look, that is a Hoffman air valve, which I use, and it was made. These vents were made very good at one point. They're not good as they used to be, but they are the best when it comes down to heating up the radiator, because they will let as much air out of that radiator as possible, and you can get maximum BTUs of heat into that radiator. A lot of people go for these because these are about $5.99, these little cheap Taiwan piece of shits. Now remember, like I told you, when you spend cheap money, you get cheap end results. So in some cases, you'll find a scenario where the valve never shuts off. So if you have a radiator running and the steam is hissing and it never stops throughout the entire heat cycle, that is completely inefficient. You want to get rid of that as quickly as you possibly can. The next common problem that happens with this is these valves tend to get split down the middle due to the steam pressure. which is another problem. And once again, it leads to fuel deficiency. You wind up having an inefficient system. If you want to go with good valves, these were a good set of valves to go with at one point. I wouldn't get these unless you are putting them into your own personal home where you can monitor and know whether something is going wrong. And if they tend to not seal the radiator or vent out the steam properly or lock out, you can easily remove them and put new valves in. The next valve that's good to use, or the next two valves that are good to use, are Hoffman, which is Gordon, which are these right here. These are pretty good to use. If you go with these, I would say use the this is the number D series air vent. This has the largest opening. You can use this on the riser pipes of the bathroom and in the kitchens on the top floors. They're not good for venting radiators. If you want to go with a Gordon's air vent to vent the radiator, go with a number 4. This has a smaller opening. The reason why I say do not go with the larger air vent, because these air vents have a float device. So basically, when you get a couple of ounces of pressure, of steam pressure inside of it, the float device will be forced closed, and basically it'll stop all air from venting out of the radiator completely. So if your radiator never heated up correctly, that means you can't get any more heat out of it because it's not going to vent correctly. So as a typical example, I'm going to blow into the vent and show you exactly when it stops. And I would say I probably got a couple of ounces of air inside of this thing that was able to completely seal this vent from venting out any more air, which would be inefficient to your radiator. A good vent I would recommend that you get, and these are a bit more expensive, these are heat timers. They don't have a float device, so I would recommend that if you put heat timer valves on your radiators, make sure that you don't have any backflow problems when it comes down to water building up in your radiator. Make sure your radiator is completely opened. It is best not to close it, because in some cases the valve might not seal the radiator correctly, and you still wind up getting backflow problems into the radiator or condensated water that builds up inside of your radiator. So you want to make sure that you have that radiator completely open. You want to have the legs pitched so that the water, you want to have some small washers under the back legs so that the condensated water can make its way back into the return line, back into the boiler. And this video tends to be getting a little long, so I'm going to cut it short, and I'm going to do another half, and I'm going to basically give you some advice on hot water radiators as well.